channel, and so today's challenge is called the smallest difference. And basically the smallest difference, I'm gonna go ahead and read the instructions here promptly. So we're gonna write a function that's gonna take in two arrays of integers. As we can see both the arrays here, and we're gonna find the pair of numbers for each array whose absolute difference is closest to 0. And it's going to return the array containing these two numbers with the number from the first array in the first position. Note the absolute difference of two ints is the distance between them on the real number line. And the absolute difference of -5 and 5 is 10, and the absolute difference of -5 and 4 is 1. And we're going to assume that it will only be a pair of numbers with the smallest difference. Okay, and so basically, as we can see in this example, is saying the absolute difference of -4 and -1 is actually 1. And we're going to do the same here. We're going to check each value from this array and this array, and we're going to return the pair of number with the smallest difference. And so I want to start off by actually writing out or commenting out what we're going to do. In this case, I would sort the array. So let's go ahead and sort the array. I'm going to say array1, and let's go ahead and sort that. We're going to use the built-in JavaScript function a and b, right? So it's implied there in the example. A minus b, right? It's going to sort the array from smallest to biggest. And let's do that to our second array, array2, sort, and then we're going to do the same thing. Right, we're going to check if this value is less than that value, and just to be clear that is indeed what's happening, let's go ahead and console log our array1 and our array2. And so what we're going to do here is basically invoke our function so we're able to see it. I'm going to label it output, and it's going to be our smallest difference taking in array1 and taking in our array2. Right, and so what we want to do now is basically console log our output. So if we were to run this, beep boop, now we can see that this is the array that we have defined in sorted manner. So let's go ahead and input that value there, and then let's go ahead and input the value here. Right, and so what we're gonna do now, let me go ahead and clear this output, and the first thing we're gonna do is set our pointers. Right, we're gonna set our pointers or our indices, right, indices, to basically keep track. Right, so let's go ahead and set our first index. We're going to call it index1, idx1, and then going to set that to 0, and then let's declare our second idx for our second array, and that's going to be set to 0. And so what we're going to be doing here is basically comparing -1 with +15. So in this case, we're going to say if -1 and +15, and we're going to check is -1 less than 15. Yes, it is. Then what is the actual difference here? And so the difference here would be equal to, if we were to compare these, it would be 14. So this would be the output. So now we need to keep track of this number. And so this is the actual difference amongst these two numbers and the smallest difference. So we need to keep checking, comparing these values, 3 with 17, up until we finish the arrays, right? And so what we want to do is basically, like mentioned earlier, we want to set and keep track of the smallest difference number, right? So in this case, it would be this one. So what we need to do here is basically declare our smallest number, and we're going to set that equal to infinity, and we're going to assign that equal to infinity to basically set the maximum value temporarily, just to store the smallest pair in the array. So the smallest, let's go ahead and set that to infinity, and then we're going to declare our current number, which we're going to use to compare, right? And so there we go, that's to keep track of the current number. And what we're going to use here, we're going to use we're going to return, it says to return here, so return an array of containing these two numbers with the number first array in the first position. So basically it's asking us to return an array of the smallest pair, right? The smallest, I guess let's just call it the smallest pair. They go to an empty array, and now we want to loop through these values. Let me go ahead and comment this out so it doesn't throw an error. And now we're going to say while, and what we want to do here inside our while loop, it says while our pointer index 1 is actually less than the value of the array 1 dot length, right? We want to make sure it's still within the bounds of the array, and then we're going to say the same thing for the other array. While there's still room to loop through, then we want to make sure that it's still also less than the array 2 and the length of the array, obviously, right? And once we're done with this, we actually want to return, let me go ahead and remove this here. We actually want to return what is it that we want to return? It says to return the smallest difference, smallest pair difference, right? And so in this case it's going to be an array. We already established that, with the first number being in the first position. And so let's go ahead and just comment this out for now, and let's use our while loop. And so within our condition, we're going to check if our first number is less than our second number, right? And so if it is, then we want to go ahead and set the current number equal to our second number minus our first number, right? And then once we do that, if this is true, then we want to go ahead and increment the index of our first array by one, right? Otherwise, we want to go check if our second number is actually less than our first number, then what we want to do is set this current equal to the first number minus our second number, right? And then we also want to increment that index 2 by the value of 1. Otherwise, then if that's not true, then we just want to go ahead and just return those two numbers, right? So we're just going to return it. There's no point of looping through. We're done, and we need to return that second number, but the first as the initial one, right? And so we pretty much have to return, we have to check if the smallest is, okay, so let's go ahead and now that we're done pseudocoding this, let's go ahead and actually write it out. We're going to say if, right, our first number, so we're going to say if our first number, which we haven't declared yet, right? So first thing we need to declare our first number, which is declare our first and second number variables to hold and compare the value, right? So we need to declare them first in order to use them. And so, because we're just keeping track of the indices here and not the actual value, so we want to keep track of the value. So we're going to say the first number, right? First number, let's set that equal to our array, right? Which is array 1. And what do we want to access? This index, IDX, right? And then our second one, second number. Let's set that equal to the array2, array2, and set that equal to idx2, right? And now this is where I was saying if our first number is less than our second number, right? So that's what we're checking. And so what we want to do here, we said we want the current number to be equal to the index, it's going to be set equal to our second number minus our first number, right? And so we're going to basically, in other words, check if this number is less than 15, then we want to say yes, this is less than 15. So we're going to move this pointer to the next one so we can compare basically right here. So we're going to use this value compared to this value. If it's less, yes. So then we want to move the pointer to the next number so we can compare these two, right? And so what we want to do here is, yes, we found it. So now we want our index 1 to our pointer to increment its value, right? And so let's go ahead and I'm just gonna remove this comment. Otherwise, else if our second number is less than our first number, meaning we're gonna iterate through, right? And so we're gonna compare the next one. Is 3 less than 15? Yes. Is 5 less than 15? Yes. Is 10 less than 15? Yes. But once we get to the 20 here, right, so in between, we obviously tested all the other ones, and then we got to the point where we are comparing 20 and still 15, right? And so we're saying basically if our 20 is less than 15, right? That's what we're saying here. If the second number is less than 15, then what do we want to do? We actually want to set the current value equal to whatever the result is of subtracting this. So if we were to subtract that, we will get 5 now as the answer, right? And now, because now that we know that this number is larger than this one, we want to increment this pointer to the right so we can compare now 20 with 17 and then also 20 with 26, right? And so this would be the current smallest difference, absolute difference. So let's go ahead and finish writing this out. Else, if our second number is less than our first number, then we want to go ahead and set that current value to our first number, right, minus our second number. All right, and so once we figure that out, let's go ahead and increment our index 2 by the value of 1. And let me go ahead and erase this. It'll put right here. And otherwise, what do we want to do? We want to just return. That means we have found our first and second number, right? Return our first and second number. Oops, first num and second num. Sweet. And so the next thing we want to do here is actually check if the smallest is greater than the current, which it will be because our smallest right now is actually set to infinity. And so we're saying if our smallest is greater than our current, which it will be true, it is larger, infinity is bigger than the current. Our current number in this case would be 5. And we want to set that value, right? We want to set this value to the smallest, so smallest should be equal to our current value. And we want our smallest difference or smallest pair, and we want to set that equal to the first number and our second number, right? And then what we want to do is just return the pair that we found. Return the smallest pair. right? And so we're going to return the smallest pair. In this case, if we were to run this, oh, I might have deleted a bracket here. And so in this case, if we were to save this, if we were to run it, we should see the output of 28 and 26. There it is, 28 and 26. So there you have it, guys. So our smallest difference would be 2. So in this case, we have 28 and with the value of 6. And that is the smallest pair. So there you have it, guys. And I'm out. Have a good day. Bye.